Hello students, today we are doing a new chapter, Inequalities. Now this chapter was not there in your old book. So this is a chapter that has been introduced this year and it's for Selena, the new publication. Selena Publishers, the recent publication has this chapter, Inequalities, and this is exercise 15. Now, what is an inequation? We've learned linear equations where we say a mathematical statement which shows that two expressions are equal. Now suppose I have 2x plus 5 and I say this is equal to 12. This is called an equation because we have an equal to sign. So we are saying that this expression is equal to this expression. Now if we have two expressions which are not equal to each other, then such a statement is called an inequality or inequation in the sense, now instead of the equal to sign, I might have a lesser than sign or I might have a greater than sign. I can say the first expression on the left hand side is greater than the one on the right, or I can say that this expression is smaller than and equal to. If you have a symbol like this, it's smaller than and equal to the other expression. Or if I say the left hand side is greater than and equal to the other expression. So these are the symbols that are used in an inequation. Okay, so we don't use the symbol equal to. The symbol equal to is used in an equation. So let's look at question 1. Find the resulting inequation when 10 is added to each side of this expression. Okay. Now, one property of inequations is that adding the same number. Now, if I take 10, if I add it to each side of the inequation, this is the left-hand side, this is the right-hand side. So adding the same number to each side of an inequation does not change the inequation or the inequality. Okay, so if I add 10 to the left-hand side and 10 to the right-hand side, the inequality remains the same. Another property is if I subtract the same number from each side of an inequation, it does not change. Similarly, if I multiply each side of an inequation by the same positive number, okay, each side by the same positive number, this does not change. If I divide again by the same positive number, it does not change. So keep these properties in mind. Adding, subtracting, the same number on both sides does not change. Multiplying and dividing the same positive number on each side does not change the inequation. So let's do the first one now. So in question 1, we have to add 10 to each side of the inequation given to us. Okay, so let's first write down the inequation. And what do we have here? We have 4x minus 3 is smaller than 2. So this is the left hand side and this is the right hand side. Now we need to add 10 to each side. So let's do that. So 4x minus 3 plus 10. So we've added 10 to the left hand side. Let's add 10 to the right hand side. 2 plus 10. Now let's simplify this. 4x. Now we can work on minus 3 plus 10. Signs are different. Put the sign of the bigger number and subtract. 10 minus 3 is 7. And this is lesser than 2 plus 10. 2 plus 10 is 12. So this is the new inequation that we have got when we added 10 to both the sides, the left hand side as well as the right hand side. Question 2. 7 is subtracted from each side. So the question is, find the resulting inequation when 7 is subtracted from each side of this expression here, this mathematical statement. So we know the property that if you add or subtract numbers from both sides, the inequation remains the same. So let's write down what is given to us. So we've been given 2x plus 5 is greater than, this is a symbol, and if you have a line below that like this, that means greater than and equal to 8. So this is the inequation given to us and we've been asked to subtract 7 from each side. So let's see, we'll get 2x plus 5 minus 7, this is the left hand side, is greater than and equal to 8 minus 7. So 2x, now work on plus 5 and minus 7. Signs are different. Put the sign of the bigger number and subtract. 7 minus 5 is 2. And this is greater than and equal to 8 minus 7 is 1. So the resulting new inequation that we have got is 2x minus 2 is greater than and equal to 1. Question 3. Find the resulting inequation when each side of this mathematical statement is multiplied by 4. That means we have to multiply the left-hand side by 4 and the right-hand side by 4 and get the new inequation. So let's write this down. So we have 3x minus 5 is smaller than or lesser than and equal to 2. Now we are going to multiply both sides by 4. Now, when you are going to multiply this side by 4, remember there are two terms. If you have only one term, you can straight away multiply. When you have two terms, put them in brackets. So that means I'm going to write 3x minus 5. I'm going to multiply this by 4. So I'm going to put 4 here. And this is lesser than and equal to 2 into 4. So multiply both sides, the left-hand side as well as the right-hand side by 4. So whenever you multiply like this, you know how to do it. We have to multiply this with each term inside the bracket. That means I have to multiply 4 into 3x first. So 4 3s are 12. So that is 12x. And then I multiply 4 into minus 5. So the sign is minus. 4 5s are 20. And here lesser than and equal to 2 4s are 8. So I've got my new inequation. What does it say? 12x minus 20 is lesser than and equal to 8. So this is my new inequation when I multiply both sides by 4. Now, question 4. Again, find the new one when each side of this statement is divided by 6. So let's do that. So now let's write down the question. So here we have 8x plus 3 is greater than 13. And now we have to divide it by 6. So that will be 8x plus 3 divided by 6. Remember, both sides we are doing it is greater than 13 divided by 6. Now remember, this is division of a binomial. 8x plus 6 is a binomial, isn't it? By a monomial. And we have done this before. So this is how we do it. We take each term separately, isn't it? We take 8x and divide it by 6. Then we take 3 and divide it by 6. This is how we divide a binomial by a monomial. And then on the other side we have 13 by 6. So now we can work on this 8x by 6 and 3 by 6. So let's cancel what we can. Now I can cancel 6 and 8 both by 2. 2 3s are 6 and here 2 4s are 8. Similarly, I can cancel these two here. 3 1s are 3, 3 2s are 6. So what do I get here? I get 4x by 3 plus 1 by 2 is greater than 13 by 6. So this is my new inequation. Okay, and now how did I get this? When I divided both sides by 6. So this is the resulting inequation. Now question 2. If the replacement set is this much, find the solution set. So what is a replacement set? Now it is a set of numbers or values from which we find the solution set or the value of x. So all these values here form the replacement set. And we have studied sets, that's why we find all these elements within brackets. So from these values, we have to find the solution set if question 1, x is lesser than 4 and question 2, x is lesser than minus 1. So let's work out the first one. First one is x is lesser than 4. So look out for 4 here, 4 is here. So all the digits to the left of 4 are lesser than 4. So that will form our solution set. So as you can see, all these that are lesser than 4 will form the solution set for question 1. Now since it's a set, we're going to put it within brackets and we're going to write all these digits. So let's write minus 4, minus 3, minus 2, minus 1, 0, 1, 2 and 3. So this is the solution set. And where did we get it from? We got it from the replacement set. Now let's move to question 2. This time x is less than minus 1. So where is minus 1? Minus 1 is here, and all the numbers lesser than minus 1 is what we need to write. So all the numbers to the left of minus 1. So these are the values of x here. So let's write it down in the form of a set. So put your curly brackets. Then we have minus 4, minus 3 and minus 2. This is the solution set for question 2. Moving on to questions 3 and 4. So question 3, let's read it correctly. X minus 3 is greater than and equal to 0. Okay, so first we need to solve this. Now here I need to find the value of x. So I can use the properties of inequalities where to find the value of x I need to remove minus 3. To remove minus 3 I can add plus 3. So minus 3 plus 3 will become 0, isn't it? So if I add plus 3 here on the left hand side, I need to add plus 3 on the right hand side also. So that is one way of doing adding and adding on both sides or subtracting on both sides. Now we can also do transposing method like we did for linear equations. So let's try the transposing method. So here x minus 3 is greater than and equal to 0. Now I need only x, so I need to remove my minus 3. So what am I going to do? I'm going to transpose my minus 3 from the left hand side and I'm going to take it to the right hand side. So when it goes to the right hand side, it becomes plus 3. So this will be x is greater than and equal to 0 plus 3. That is x is greater than and equal to 3. Okay, so we have solved that easily. Now let's go back to our replacement set and look at all the numbers that are greater than 3 first. Greater than 3, we have only 4 and 5. And the question says greater than and equal to 3. That means we include 3 also. So our solution set will be 3, 4 and 5. So let's write that. So x is equal to, okay, so this will be 3, 4 and 5. So our solution set, we'll put it within curly brackets, is 3, 4 and 5. So we have found the answer. X is in the form of a solution set here. The values of x are 3, 4 and 5. Now let's go to the next question. 2x is greater than 6. Again, we need to find the value only of x. So we need to remove 2. So let's use the transposing method again. So this is 2 into x. 2x is 2 into x is greater than 6. I need only x here. Let's put the same symbol. We'll have 6 on the right hand side. I'm going to transpose 2 to the right hand side. It's multiplication. On the left hand side, when I move there, it becomes division. So that is 6 divided by 2. So x is greater than 6 divided by 2 is 3. X is greater than 3. So go back to your solution set and look out for all numbers greater than 3. We have only 4 and 5. So we have found the solution set here. X is equal to 4 and 5. Let's put it in the form of a solution set. 4 and 5. So this is a solution set. 4 and 5. Question 5. Here it says 3 by 2 plus x is lesser than and equal to 1 by 2. Okay, so let's use the transposing method again. We will write the question first. 3 by 2 plus x is lesser than and equal to 1 by 2. Now we want only the value of x. So leave it on the left hand side. Leave the symbol there. 1 by 2 on the right hand side as it is. Now we're going to transpose 3 by 2 to the right hand side. And it's addition on the left. So when it comes here, it becomes subtraction by 3 by 2. So now let's find the solution to this. Let's simplify this. We have to find 1 by 2 minus 3 by 2, which is division or subtraction of fractions, isn't it? So let's do it. Now 1 by 2 minus 3 by 2. Now the denominators are the same, so we can use the same thing as our LCM and just subtract the numerators. So 1 minus 3. So this is minus 1 minus 2 by 2. isn't it? 1 minus 3 is minus 2. Minus 2 by 2. Now you can cancel the numerator and the denominator because both are 2's. So finally we have minus 1. So let's write that down here. So x is lesser than and equal to minus 1. So x is lesser than and equal to minus 1. Let's go to our replacement set and look for all the numbers that are lesser than minus 1. So first the numbers lesser than minus 1 are minus 2, minus 3, minus 4, and it says lesser than and equal to minus 1. That means we have to include minus 1 also. So our answer will consist of all these numbers. So x is equal to minus 4, minus 3, minus 2 and minus 1. And since we're asked to find the solution set, we put it in the form of a set, that means curly brackets, and put all these values inside. These are all the values for x. Now question 3. If the replacement set is set of whole numbers between minus 2 and 6, find the solution set. So first we need to write the replacement set. Now let's be very careful when we read the question, because it says it's a set of whole numbers between minus 2 and 6. So first let's write all the whole numbers between minus 2 and 6. All the numbers, okay? So we will not write minus 2, we will not write 6. We're only going to write all the numbers between minus 2 and 6. So that will be minus 1, 0, 1, 2, 3, 4 and 5. But here it says the replacement set is a set of whole numbers. So here, what are all the whole numbers that you can see? We can only see numbers 0, 1, 2, 3, 4 and 5. Minus 1 is not a whole number. So our replacement set will only have numbers from 0 to 5. So we need to write our replacement set first. So we have our replacement set here. The set has elements from 0 to 5. Now we have to answer our question. So first let's read our question. Minus 5 is less than x, which is less than 4. So when you have x like this in between, you need to write all the numbers between this and this. Okay, so all the numbers less than 4, that is what the value of x is up to minus 5. So as you can see in your replacement set, we have numbers less than 4 will be all the numbers to the left of 4. That is 0, 1, 2 and 3. These are all the numbers less than 4. So now let's write our solution set. Our solution set will be 0, 1, 2 and 3. This is our solution set. Question 2. So here we have 2x minus 3 is greater than and equal to 5. So first let's solve this. Let's find the value of x here. So I'll write down the question. 2x minus 3 is greater than and equal to 5. So 2x is greater than and equal to 5 plus 3, because I have transposed minus 3 to the right hand side. It's become plus 3. So 2x is greater than and equal to 5 plus 3 is 8. Now I need to find the value of only x. So we are doing it just like our normal linear equations. So 8 is on the right hand side. 2 is multiplication, which I'm going to transpose to the right hand side. It will now become division. 8 divided by 2. So x is greater than and equal to, divide this, 2 4s are 8. Greater than and equal to 4. So now go back to your replacement set and look at all the numbers greater than 4. We have only 5. And it also says greater than and equal to 4. So we'll have 4 and 5. So our solution set will have the elements 4 and 5. This is our answer. Question 3. 3x minus 5 is lesser than and equal to 10. So first let's solve it. Find the value of x. Okay, so this will be 3x minus 5. I'm copying the question. Is lesser than and equal to 10. So 3x is lesser than and equal to 10 plus 5, because I have transposed minus 5 from the left hand side to the right hand side. So 3x is lesser than and equal to 10 plus 5 is 15. Now we can find the value of x. X is lesser than and equal to 15 divided by 3. divided by 3 because I have transposed 3, which is multiplication here, to the right hand side. So x is lesser than and equal to, now 15 divided by 3 is 5. Okay, so here I write 5. So what does this say? Now let's read this. X is lesser than 5. It's also equal to 5. So let's look at all those numbers lesser than 5. All the numbers lesser than 5 is up to 4 and it's also equal to 5. So our solution set is the same as our replacement set. So let's write our answer. Our solution set 0, 1, 2, 3, 4 and 5. So we've got a solution set there. Moving on to question 4. 2 is lesser than x, which is lesser than and equal to 7. Okay, now if you have to read from the point of view of x, you can say x is greater than 2 and less than and equal to 7. So you can write all the numbers greater than 2. So what are all the numbers greater than 2 here? We have 3, 4 and 5 are greater, and look at the other part which says lesser than and equal to 7. Now we don't have 7 there, isn't it? So these are the numbers of our solution set. So let's write our solution set here: 3, 4 and 5. Question 5. So let's read this question. Now 0 is less than and equal to x, which is less than and equal to 6. Or you can say x is greater than and equal to 0 and less than and equal to 6. Okay, so x is greater than and equal to 0. So let's just do that part first. It's greater than and equal to 0. So all the numbers that are greater than 0 and equal to 0. And look at the other part. X is less than and equal to 6. Now we don't have 6 here. So it's less than 6. So we write all the numbers less than 6. So that is our solution set. Our solution set will have the values of x as 0, 1, 2, 3, 4 and 5. This is our solution set. Question 4. Represent the solution set for each of the following inequations on the number line. So first we need to get the solution set and then we have to show that on a number line. So let's read this question. X minus 5 is lesser than and equal to 2. So which is the replacement set? W. X belongs to W. And what does W stand for? Whole numbers. So what are whole numbers? Whole numbers are numbers starting from 0. 0, 1, 2, 3 and so on. This is a set of whole numbers. So let's read the question once again now. X minus 5 is lesser than and equal to 2 and x belongs to whole numbers, a set of whole numbers. So let's solve this portion first. X minus 5 is lesser than and equal to 2. So let's write that question down. X minus 5 is lesser than and equal to 2. So now we want to find the value of x. So we'll say x is lesser than and equal to 2 plus 5. We have transposed minus 5 from the left hand side to the right hand side. So it's become plus 5. So x is lesser than and equal to 2 plus 5 is 7. So now we can get our solution set. So what is x equal to? All numbers that are lesser than 7 and equal to 7. So what are all the numbers lesser than 7? Starting from 0. We can write all the numbers up to 7 first. So 0, 1, 2, 3, 4, 5, 6. These are all whole numbers less than 7. Now it says x is equal to 7 also. So we include 7. So this is the solution set. So now let's draw a number line. So we have a number line drawn here. So let's represent some whole numbers here. Let's start with 0 here. So that will be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, we can stop at 9. And this side is all the negative numbers. But we are looking at whole numbers only, isn't it? So we are looking at a number line which is starting only from 0. So here now let's represent the solution set here. So x is equal to all these values. Okay, so now we're going to show this on the number line. So let's mark all these. So we have 0 here, then we have 1, then we have, that's 1, 2, 3, 4, 5, 6, 7. That's it. We stop at 7 because x is equal to 0, starting from 0 right up to 7. So we have shown all our numbers, the values for x on the number line. So this is a solution set that is shown on the number line. Let's go on to the next one. Question 2. 2x minus 3 is less than 7 and x belongs to natural numbers. So let's write a replacement set for natural numbers. So that will be, natural numbers are counting numbers that start from 1. So 1, 2, 3, 4, 5 and so on. All these numbers are natural numbers starting from 1. So this is your replacement set. Now let's find the solution for x now. 2x minus 3 is less than 7. So 2x will be less than 7 plus 3. Okay, because we are transposing minus 3 to the right hand side, it becomes plus 3. So 2x is less than 7 plus 3 is 10. Therefore, x is less than 10 divided by 2. How did it become division? Here 2 is multiplication, 2 into x. So I have taken it to the right hand side, from the left hand side to the right hand side. So it's become division. So x is less than 10 divided by 2 is 5. So x is less than 5. So let's find the solution set for x. The solution set for x will be all natural numbers less than 5. And we can see it here, 5 is here. We will not write 5 because it says x is less than 5. So all numbers less than 5. So we just have 1, 2, 3 and 4. So let's write the solution set 1, 2, 3 and 4. So now let's show this on the number line. So draw a number line and let's have numbers 0, 1, 2, 3, 4. We can write numbers, a few numbers on both sides. We can have the negative and the positive and then show only what is required. So here we have to show 1, 2, 3 and 4. So now let's do that. We'll do that. So we have 1, 2, 3 and 4. So this is our solution set for this answer. Okay, so we've got 1, 2, 3 and 4 which we have shown on the number line. Let's question 3. Question 3. 5x plus 12 is greater than minus 13 and x belongs to I is integers. So x belongs to the set of integers. So let's write the replacement set first, that is the set of integers. So we'll start from say minus 7, minus 7, minus 6, minus 5, minus 4, minus 3, minus 2, minus 1, 0, 1, 2, and this goes on the right hand side. Similarly, on the left also it goes on. Before minus 7 also there are more numbers. So now let's solve for x. 5x plus 12 is greater than minus 13. So 5x is greater than minus 13 minus 12. So 5x is greater than, now minus 13 minus 12, signs are the same, so put the same sign and add. 13 plus 12 is 25. So 5x is greater than 25, then x is greater than minus 25 divided by 5. So x will be greater than, now we can solve this, here it is plus, so minus into plus is minus first, and then we can cancel 5 and 25. 5 5s are 25. So x is greater than minus 5. So now we can get the solution set for x. So what are all the numbers greater than minus 5 here? That means all the numbers to the right of minus 5 are greater than minus 5, isn't it? So all these numbers. So let's write down a few numbers. That is starting from minus 4, minus 4, minus 3, minus 2, minus 1, 0, 1, 2, and so on. This goes on. Okay, so this is the solution set. Let's draw a number line. So number line also we can show all these numbers that we have on the replacement set. Let's try minus 7, minus 6, minus 5, minus 4, minus 3, minus 2, minus 1, 0. And let's write a few positive numbers. 1, 2, 3, 4, 5 and 6 also we can have. Okay. Now let's go back to the solution set. So we are going to represent all these numbers on the number line. So let's do that. So let's start with 4, minus 4. So you can draw a dot there or highlight it in some way. Minus 4, minus 3, minus 2, minus 1. Then we have 0, 1, 2, 3, 4, 5 and 6. And this goes on. Okay, you know it doesn't end here, it goes on and on. So we have shown our solution set on the number line. Question 4. 3x minus 15 is greater than and equal to 15 and x belongs to natural numbers. So first we have to get the replacement set with natural numbers. So let's get that. So n is natural numbers and natural numbers are numbers that start from 1. They are counting numbers 1, 2, 3, 4 and so on. So this goes on endlessly. So n is a set of natural numbers and x belongs to n. So now let's solve for x. 3x minus 15 is greater than and equal to 15. So 3x is greater than and equal to 15 plus 15. That is 3x is greater than and equal to 15 plus 15 is 30. So if 3x is greater than and equal to 30, then x will be greater than and equal to 30 divided by 3. Now each time we are transposing. So here we have transposed 3 to the other side and it's become division. So now this will be x is greater than and equal to 30 divided by 3. Now we know that 3 tens are 30. So here x is greater than and equal to 10. So now let's get our solution set. So x is equal to all numbers that are greater than 10 and equal to 10 and we have to choose it from this replacement set. Though we've written only up to 4 numbers here, you know that there are many more numbers. So we can write numbers starting from 10 because it says equal to also, isn't it? So starting from 10 and a few numbers that go on to show that it goes on indefinitely. So let's write 10, 11, 12, 13 and a few numbers that go on indefinitely. So now let's draw a number line. So we have a number line. We can have a few numbers starting from 10 here. 10, 11, 12, 13, 14, 15, 16. And we can have a few numbers this side also. 9, 8, 7, 6, 5, 4, 3. Okay, so this arrow mark here, this arrowhead here shows that numbers are going on indefinitely this side. And here also it shows it goes on indefinitely on the right side. Natural numbers are going ahead on the right side, whereas on the left side, natural numbers will stop at 1. Okay, now let's mark the solution set. The values of x, let's mark on the number line. So let's start with 10. So we have 10 here. So, and then we have 11, and then we have 12, 13. Now go on, 14, 15, 16. Now because, what does this say? It says x is equal to 10, 11, 12, 13 and it's going on. Okay, so we are not stopping at 16. What we will do is to show that this is going ahead, we are going to highlight this arrowhead this side. The arrowhead on the right hand side, we are highlighting it just like we highlighted all these numbers, just to show that this goes on. The numbers on the right side is going on. Question 5. 2x plus 5 is lesser than and equal to minus 3 and x belongs to I, that is the set of integers. So let's write our replacement set first. So we have I, which stands for integers, and we have some negative numbers. Let's start from say minus 7. Minus 7, minus 6, minus 5, minus 4, minus 3, minus 2, minus 1, 0, and we can include a few positive numbers. Now this will go on the right hand side. Similarly, on the left also it will go on. There are many more numbers. So the set of integers has been shown here. Now let's solve for x. 2x plus 5 is lesser than and equal to minus 3. So 2x is lesser than and equal to minus 3 minus 5, because we have transposed plus 5 from the left hand side to the right. It's become minus 5. So 2x is less than and equal to minus 3 minus 5, signs are the same. Put the same sign and add. 3 plus 5 is 8. So 2x is less. So x will be lesser than and equal to minus 8 divided by 2, because here it is multiplication on the left hand side. As you can see, it is multiplication. So when we move 2 to the right hand side, it becomes division. So now we can solve for x here. X is lesser than and equal to, now let's do minus 8 divided by plus 2. So minus into plus is minus, 8 divided by 2 is 4. So x is lesser than and equal to minus 4. As you can see, x is lesser than and equal to minus 4. So let's write our solution set for that. So our solution set is the values of x. So all numbers less than minus 4. What are the numbers less than minus 4? Minus 5, minus 6, minus 7, and so on. And it says equal to also. So we will include minus 4 also. So let's have all these numbers in our solution set. So we have to have our dots to show that it goes on the left hand side. Then we have minus 7, minus 6, minus 5, minus 4. So we stop with that. So this is a solution set, and let's show this on our number line. So we have the number line, and let's show these numbers there. So let's start with minus 7, minus 6, minus 5, minus 4, minus 3, minus 2, minus 1, 0. And then we can write the positive numbers also, because this is a set of integers. Okay, so now here we need to show values of x. So the values of x will be, now we have minus 7, minus 6. So let's show that minus 7, minus 6, minus 5, minus 4. And remember, this is going on this side. It is going on continuously on this side. So these are the values of x, and this is our solution set. So we have represented the solution set on the number line. So remember to do it this way, children. Mark it. You can put a dot over these numbers, or you can highlight it in some way to show the values of x. So we will stop with this for now. In our next video, we will continue with the remaining questions. Thank you, children.